Welcome to Math Cafe. Enjoy math, sip by sip. Today we are going to see third part of the chapter Relations and Functions from grade 12. So I hope you have enjoyed watching the first two parts about the different types of relations. So here we are going to see the second part of the chapter. It is the types of functions. So today's objective is identify different types of functions. What is a function? A function is just like a program. If you give an input, it will give some output based on whatever is your input. One input can't have multiple outputs, whereas more than one input can have same output. So here there will be an operator. That's what it means. Say you are inputting 2, x plus 2, you will get the answer as 4. Can you study in two different schools at the same time? Never, right? You are always associated with one of the school. So your student's life will be always a function. For each student, there will be exactly one school at a time is only possible. So that is the basic definition of function that we have already seen. How do you check a function? Function is basically a special type of relation. A relation f from a set A to a set B is called a function if every element of set A has one and only one image in set B. A function is a relation such that no two pairs in the relation has the same first element. And how do you check a relationship is a function or not? The best way, if you can sketch a graph. So I have taken two examples here, two graphs I have drawn here. And if you can draw a vertical line and if it crosses only at one point, that means it is a function. So wherever you draw on the graph and if it crosses only at one single point, we call it as a function. Now, you consider the first one, what I have drawn here. Say this is another graph. See clearly this graph is crossing at 2 points. So this is what I have written in this case here. No two pairs in the relation is same first element. So here if you take for example, if this point is x coordinate is 1, definitely the 1 has two different y coordinates and it is not a function. So this is one of the easiest technique. Generally when you try some MCQs and all, this will help you easily. If you can sketch the graph, draw a vertical line. If it crosses only a single point, it is function. Otherwise, it is not a function. Now we are going to see the main idea of this video, that is types of functions. What are different types of function? That's what we are going to see. Two sets. One set is your class, that is 12a, and then another class, say it is 12b. So now I'm considering the relationship as friends, and I am defining the elements like this way. Say maybe 5 elements are there, and here there are some 6 people in that one. Now if every student from 12A is having a different friend in the 12B class, each of the 12A student is having a different friend in 12B, then such a function, if you notice that every person is having a distinct image in the second set. So such a function we'll call it as a 1-1 function or an injective function. So a function in which every first element is having a different image in the second set. So that is called a 1-1 function. Can friendship be always a 1-1 function? Very rare, right? If you take in your class of 12A, many people have like a lot of common friends in 12B, and then generally it will not be 1-1. This is an ideal case in which each element is having different image in the second set, so that we call it as a 1-1 or injective function. Now say this I said A and B or 12A and 12B. Now suppose that I need to define a function from B to A. Can you say that relation from B to A in this arrow diagram is a function or not? I think you got the answer correctly. It's not a function because there is one element is free here. Whenever we talk about a function, we given top priority to the first set. Now in this case, we are giving more importance to the second set, and if you see here, there is one element is free. Suppose this element is not there, then you can easily define a function from B to A. A special case, we call it as another type of function, an onto function. So you remember this function, the range is a subset of the whole codomain B. Now if I remove this x, this range became exactly the codomain. Or if no element is free in the second set. I repeat, if no element is free in the second set, such a function is called an onto or surjective function. So this is our topic, types of functions, one and onto. See here again taken another example. So these are a trivial example. In the first case, this is 1 and here there is no element free, so it is onto. So if a function is satisfying both the conditions, we call it as 1 and onto function, or it is called a bijective function. Bijective function. So this is the actual definitions for your convenience and understanding. A function f from x to y is defined to be 1 or injective if the images of distinct elements of x under f are distinct. Now, how do we check the given function is 1 or not? So that's what this says. For every x1, x2 in the first set, f of x1 equal to f of x2 gives you x1 equal to x2. This means that like this way. So if these images are same, like from 12a, a and b are having images, suppose p and q. If p and q are equal, the corresponding elements also equal. That's what it says. Or another way will say, if these elements p and q are not equal, then you can say that what? These elements a and b also must be not equal. So this is one way of expressing. There is another way, as I said. If f of x1 not equal to f of x2, then x1 is not equal to x2. So that is a way of checking whether the given function is 1 or not. Onto or a surjective function. If every element of y is the image of some element of x under f, we consider the same function f from x to y. So no element is free in the second set, that is called the onto function. So for every y in y, there exists an element x in x such that f of x is equal to y, that is range f is equal to codomain. If the function is both 1 and onto, we call it as a bijective function. Listen, for your convenience, I keep a slide at the last of each video, the recap of the particular videos. That concepts whatever I explain, I keep it as like a ready reference at the end of the things. So you can always refer and you can take a snapshot and keep it with you for the further reference. Taking one example, see the arrow diagrams are there. See these elements are mapped here like this way. Now see each element, -1 maps to 4, 2, 16, 3, -12, -3 to 7, 5 to -5. So this is clearly a 1 function because each element is having distinct image in the second set. Now is it onto? Clearly it is not, because the element 3 here free. This 3 is not related with any element of the first set, so it is not a onto function. Consider the second case here. See here, if you see, every element is mapped with the different elements and there is no element is free. So it is a onto function. So that is another case. So we can also say this is 1 and onto. Now you can have that is, now we'll go for another example. Say this one, arrow diagram. See, if you observe here, all the elements are having one image. That means many elements having one image. It's a simple example from generally from your class. All students having the common image as the teacher. So such function we call it as many one function. So that is another type of function. So we have seen types of functions as 1, onto, and then many one. Generally 1 and onto means we call it as what? A bijective function. Now we'll see some examples. So the first question I have taken as this here. A function f from n to n given by f of x is equal to x square. And I need to check whether this is 1 and onto bijective. So how do we proceed mean for all these questions? There is a common algorithm. So what we need to say that what? Take two elements from the first set, that x1 comma x2 belongs to n, and say that f of x1 equal to f of x2. So this basically what you're trying to say is that you have the elements x1, x2 in the first set, and here you have the elements f of x1 and x2. So what we are trying to say is that if these two images are equal, correspondingly the elements also must be what same. So that's what we are trying to get it. So the first step is take two elements in the first set and assume that f of x1 equal f of x2. Now what is f of x1 equal to? it is x1 square equal to x2 square. Now if you take x1 square equal to x2 square, you know that usually will get a plus or minus, because 2 square equal to 4 and minus 2 square also will be 4. But as this x1 and x2 are from the natural numbers, there is no plus or minus case arises. So it will be just x1 equal to x2 for every x1 comma x2 belongs to n. This satisfies only because of we have considered the natural numbers. So I repeat, whenever you want to prove something is true in math, prove generally, and whenever you want to say something is wrong, take a counterexample. So we proved that, so it is 1, 1. Now I need to consider the second part, that is onto. Now onto means what you will think. All the elements of the second set is connected with the first elements. Again here also, if you roughly work some ordered pairs, if you write f of x in the form ordered pairs, see 1, 1, and if you take a 2, 2, 4, that will come 3, 9. That's enough. You don't want to write many elements. That clearly says after 1, the 4 only has a image. So you choose let y, the second set element, as anything other than a perfect square. So if I take y is equal to 2, x square is equal to 2, that gives x is equal to plus or minus root 2, clearly which does not belongs to the natural number. Therefore, it is not on. Now the same example we'll look for with different set A and B. Now the same question, see, have you noticed I have modified z to c. So set of all integers to integers. Now again I need to get whether this function is 1, 1 and onto. So as I said in the previous case, if you write some elements, it will give you clearly an idea 1, 1. Then if you take minus 1 again, it will be 1. And then 2, 4, etc. will come. Otherwise, what you need to check is that, can I get for two different numbers the same image? So clearly here you know that f of 1 is equal to 1 and f of minus 1 also what 1. Because we know that when you are squaring, both the positive and negative numbers will give you the same answer. This is one of the examples. There are millions of examples you can come across and you can choose any one. So what we'll write, that is f of 1 is equal to f of negative 1, but 1 is not equal to minus 1. Therefore, f is not 1, 1. Now again, how do we say it is not onto? Okay, you rightly guessed. You take the same example as the last one what we have taken. Let y is equal to 2. So x square is equal to root 2 plus or minus root 2. Okay, for onto part, we let y is equal to 2. So x square is equal to 2. That gives x is equal to plus or minus root 2, and which clearly it does not belongs to z, so it is not on. Hope you got that one. Now I am going for the third example. Again the same function, f is from r to r, given by f of x is equal to x square. Here the same logic you can say clearly f of 1 is equal to 1 square, that is equal to 1, and f of minus 1 is equal to minus 1 square, that is equal to 1. So f of 1 is equal to f of minus 1, but 1 is not equal to minus 1. Therefore, f is not 1, 1. Can I take the same example? Y is equal to 2. If you take y is equal to 2, we get x is equal to plus or minus root 2. But root 2 is what? Again, a real number. Now, here you need to think like this way. Can I find square root of all the numbers, or do I get always square root of a number as a real number? Is there any other case where I will not get a real number? Yes, I think you got that one. You take any negative number. So here I will say let y is equal to negative 2. So x square is equal to negative 2. Therefore x is equal to what? Plus or minus root minus 2. See, this is complex number and which is not a part of the real number. So it is not onto or surjective. So these all are same question. I have used different domain and codomain to get the idea very well. This is the algorithm. Take two elements from the domain and assume that their images are equal, and you try to simplify to get whether the elements are also equal or not. So you assume that the outputs are equal, then you are checking whether these inputs are also the same. Now we'll go for some other questions. Like, see, this is one of the most important function in math, greatest integer function. The function is given by f of x is equal to greatest integer part of x is neither 1 1 nor 1 2. We need to prove. This means where this function denotes the greatest integer less than or equal to x. Hope for starting I'll just give an idea about this greatest integer function. This 2.9 means it is an integer not exceeding 2.9 means you should find the integer which is less than or equal to 2.9. The integer part will be 2. So if you take 3.1, that will be 3. So if you take 3.3, that will give you what? 3. So this clearly says it cannot be 1 1, right? I have taken already an example in such a way that 3.1 and 3.3 give you the same. Not only 3.1, 3.001, 3.02, everything will give you 3. All the values from 3 to 4, not including 4, will give you 3. Just say an example again. F of 3.1, 3. F of 3.2, again 3. That is, f of 3.1 is equal to f of 3.2. But 3.1 not equal to 3.2. Therefore, f is not 1, 1. Now see here, I took 3.1. You can take any decimal number the same way, like a 2.3 or 2.4, like that. Whichever number you take, you will always get it is not 1, 1. Now, how do we prove it is not 1? As you seen here, see, always the answer is an integer. Can you get y as any decimal number? Just assume a number, let y is equal to maybe 3.1. Can we get integer part of some number is equal to 3.1? This is never possible because it violates the very essential condition of the integer function, or it violates the definition of greatest integer function, because it says you will get always an integer which is less than or equal to x, but 3.1 is not an integer. This is not possible, so it is not 1. We are going for another example. See, this is f of x is equal to mod x. Hope you remember what is this modulus of x means. Again, here also you know that if you take modulus of 1, it is a 1, and modulus of minus 1, it is 1. So that means f of 1 is equal to 1, and f of minus 1 also what? Modulus of minus 1, that also 1. So that is f of 1 is equal to f of minus 1, but 1 is not equal to minus 1, so it is not 1, 1. Now what about onto part? So can you get modulus of a number anything is equal to negative? Never, right? So you assume let y is equal to any negative number, say y is equal to negative. So you will get modulus of x is equal to minus 2, which is not possible. This is not possible, right? You will never get mod x is equal to negative 2, so clearly it is not 1. And again here you can choose any negative number. Any negative number will give you it is not 1. And similarly for 1 1 you can use any pair of numbers which are equal in magnitude but opposite in signs. So this is another example. There are two sets given 1 2 3 4 5 6 7 and the function is written 1 4 2 5 3 6. Show that f is 1. See clearly here the elements is 1 is mapped with 4 and 2 is mapped with 5 and 3 is mapped with 6. So in the first set you have 3 elements 1 2 3 and each one is mapped with different elements. Clearly it is 1 1. This all symbol 1 mark or MCQ type questions, so you can say clearly it is 1 1. Is it on to? See there is a 7 included here, but 7 is not mapped with 1, so it is not on. This is not asking the question, so just you can get the question in that way also. We need to prove that the given function is on to. So say let y is equal to 3 minus 4x. So what we do that the first step is that assume the given function is equal to y. Now the second step is rearrange the function in such a way that you make everything in terms of y. That means write x is equal to 3 minus y by 4. This is our second stage. The first step, write y is equal to the function. Second step, rearrange the function in such a way that x is equal to the entire y part, or the right side should be free from x. Now we'll just do a confirmation. We'll calculate what is f of x. F of x must be y. So this is f of 3 minus y by 4. This will give you 3 minus, because f of x is equal to 3 minus 4x. So 3 minus 4 into 3 minus y by 4. This 4 and 4 get cancelled. 3 minus 3 minus of minus is y. So we got it as y. Therefore, the function is on. Therefore, it is a bijective function. This is the way we prove it is 1, 1 and onto always. 1, 1 I have explained. So, how do we proceed for onto part means you take y equal to the given function, first step. Second step, rearrange the function, the expression in such a way that write x in terms of y alone. Please, a word of caution, the right side should be always free from x. Just x in terms of y alone. And the third and final step is just like the confirmatory test, like you put the value of x in the function and cross check, it becomes y. Normally this will be always true, but just to confirm, we have done in the right way. Here I have taken another question, say this is f from R to R defined by f of x is equal to 1 plus x square. So these are all real numbers. Then we need to know that whether it is 1, 1 and onto. Suppose the question is verify it is 1, 1 and onto. How do we check always, or how do we get it an idea whether this is correct or not? Before solving this question, I will show you a shortcut trick or a tip to check whether this function is 1, 1 or not. So you remember in the beginning I said if you draw a vertical line and if it crosses exactly at one point, it says it is a function. Now to check it is 1, 1, what you can do that? You draw a horizontal line, and if it crosses more than one point of the function, it is clearly not 1, 1. If you draw a horizontal line on the graph of the function and if it crosses more than 1 points, it is not a 1, 1 function. How it works? See, if you observe here, you are inputting one x value here, maybe 2, and you are inputting another value, say maybe minus 3. See, if you can observe, the y coordinates are the same. Basically, the first degree linear expressions will be generally 1, 1 and onto always, but quadratic expressions need not be always 1, 1 and onto. To verify this question is 1, 1 and onto, same like the previous one, will start with generally also you can do, with an example also you can do. So as x square comes, you can easily go for an example. Say if I take f of 1, 1 plus 1 square, I like to take 1 always because that's the easiest calculation, and minus 1, 1 plus minus 1 out square is what? Again 2. So f of 1 is equal to f of minus 1, but 1 is not equal to minus 1, so it is not 1, 1. Okay. Can we say it is onto? Again, if you know the graph of a function, you have already done. See, this graph starts from here, but the real numbers means everything will come. Onto means we are looking all the y values are there possible or not. See, clearly all the values below this point is not included in the graph, so it is not onto. Otherwise, you can just take an example and to say, these are all shortcut methods or tricks to do the MCQs or the short questions. Descriptive, please write the answer to gain the full credits. If I take y is equal to minus 2, you can take any negative number. This is y is equal to minus 2. 1 plus x square is equal to minus 2. So x square is equal to minus 3. Therefore, x is equal to plus or minus root minus 3, which does not belongs to R. See, please try to understand. This is not the graph of this function. This is just an example I have used. So don't misunderstand. The graph of this function is not like this. If you want, I will just draw. This will be the graph of the question 1 plus x square. This point will be. These are all some typical questions usually comes in the examination. F of x is x by x square plus 1, and we need to show that neither 1, 1 nor onto. When say it is already said it is neither 1, 1 nor onto, you don't want to worry. You need to just figure it out some examples. This is a fraction. I am trying to use first of all say f of 2. If I take f of 2, this is 2 by 2 square plus 1, clearly 2 by 5. Now I will consider f of half. It will be half divided by half square plus 1. Further simplifying, 1 by 2 by 1 by 4 plus 1. This will become what? 1 by 2 by 1 plus 4 by 4. Or this is 1 by 2 into 4 by 5. Cut that, get what? 2 by 5. f of 2 equal to f of half, but 2 is not equal to half. Therefore, f is not 1, 1. These questions and all you must be seen before, otherwise you will take a long time to complete in the examination. Here, this I taken 2.5. Here you can take any number and its reciprocal, it will work. Any number and its reciprocal, it will work. But not 0 and 1 by 0. Now we need to say it is not on. So for that not onto, I will take an element. Say this is 1 is an element of all the real numbers. And say let y is equal to 1. So we'll get x by x square plus 1 is equal to what? 1. X is equal to x square plus 1 or x square minus x plus 1 is equal to 0. This is a quadratic expression. What am I trying to do? I am trying to say that there will be no value of x or no real value of x will satisfy this equation. No solving, just go for the discriminant. So discriminant will be b square minus 4ac. So minus 1 square into 4 into 1 into 1. So this is minus 3. 1 minus 4 minus 3 less than 0. So no real roots. That means this equation has no real root means what? Y is equal to 1 will have no pre-image in the first set. So it is not on. As y cannot be 1 because when y is equal to 1 you are not getting any x value in the first set. That means y is equal to 1 is free in the codomain. So it is not an onto function. This function is neither 1 1 nor on. This is another important question. This also repeatedly asked in the examinations. Here the function is given as f from n to n defined by f of x is equal to x square plus x plus 1 is 1 1 but not on. They already said it is 1 1. We have to go the same way. Let x1 comma x2 are elements of the natural numbers and f of x1 equal to f of x2 I am assuming. That means I am assumed as the images of two different elements are the same. x1 square plus x2 plus 1. Sorry, this is x2 square and this is what? x1. I have assumed that the two images are same. That means x1 square plus x1 plus 1 equal to x2 square plus x2 plus 1. Simplify and I need to check whether the corresponding elements are same or not. Taking every elements on the same side. So x1 square minus x2 square, x1 minus x2 equal to 0. I just modified, okay. So this is x1 minus x2 into x1 plus x2, pure factorization. And here also this is x1 minus x2. Now you can notice that, see here clearly, this x1 minus x2 is common. Take it out. So we'll get x1 plus x2 plus 1 equal to 0. So therefore, either x1 minus x2 could be 0 or x1 plus x2 plus 1 equal to 0. Don't just conclude x1 equal to x2 here and don't discard this. That's the common practice. Don't do that one. Now after this, what you need to check is that can this expression be 0 or not? This expression, will it be 0? These are natural numbers, add up to 0. Is it possible? 1 plus 2 plus 3 plus 4, such numbers will never be equal. So here you must add this condition before going for the final conclusion. For every x1 comma x2 belongs to the natural numbers, x1 plus x2 plus 1 can never be 0. This is very important. This should not be skipped. Therefore, you must get x1 equal to x2. That says f is 1 1. For every natural numbers, if you add 3 natural numbers, you can think it will never be 0. That is why x1 equal to x2. Now we need to check the onto part of the function. I will assume y is equal to 1. 1 is an element of natural numbers clearly, right? 1 is an element of natural number. Let y is equal to 1. So this will give you x square plus x plus 1 equal to 1. Here also you can choose any number in such a way that will give you a value which is not a part of the natural numbers. You need to choose any natural number in such a way that gives you a value of x which is not a part of the natural number. I choose y is equal to 1. This will give you x square plus x is equal to 0 or x into x plus 1 is equal to 0 or x is equal to 0 or x plus 1 is equal to 0. X is equal to minus 1. Now clearly both these numbers x is equal to 0 comma minus 1 does not a part of the natural numbers. Both x is equal to 0 and minus 1 are not part of the natural numbers, therefore not on. These last few questions are the most important questions, usually comes in the examination. Now, as I promised, like I am giving you the gist of this topic 1 and on 2, you can have a screenshot and then save it and keep it with you that you can refer at any time. Thank you for watching Math Cafe. I hope you enjoy the videos. If you like the video, please like, share and subscribe. Thank you for watching Math Cafe. Enjoy math, sip by sip. dineshformath@gmail.com. See you in the next video with composition of functions and invertible functions. Thank you.